Aloha class, today is FTOC type of problems. Remember, we are in those grind days. So let's get these problems down pat, right? The fundamental theorem of calculus and then these graph type of questions, all right? Some of these can be a little bit tough, but hopefully after 4 of these bad boys, we're going to feel a little bit more confident about them. All right, here we go. 2018, number 3. A, B, C, D. So a good 4 parts to this guy. Okay, first question here. We have a graph of a continuous function, g, and it says g happens to be the derivative of f. So real important here, the way I'd start this, guys, I would probably say this is also f prime, okay? The function g is a piecewise linear from -5 to +3. If you notice, it just kind of jumps some up there, but they're all linear, they're all lines. But then after 3, so from 3 to 6, you get something that's a little bit parabolic. Okay, very important to make sure we pay attention to that. Okay, now they tell me in part A to find f of -5. Now remember, if I want to find out what f of -5 is, it'd really be helpful if they gave me something to start with, and booyah, right there. They're giving me f of 1 to start out with. And then believe it or not, class, it's just as easy as this. If I'm at f of 1, to know what f of -5 is, I'm just going to go backwards. Boom, right? And then, hey, since I'm trying to find f of -5, I would take the antiderivative of the derivative, right? And it's going to get me back to -5. Okay, guys? Now, if you remember in class, I specifically have said this many a times. We can deal with limits going backwards, okay? But when I'm looking at it graphically, I could unfortunately make little mistakes. So what I want to do in this situation is let's go ahead and use that initial value. That's tree. But I'm going to go ahead and flip this. And remember, I flip it, I just got to change that sign on the outside. Now I can just read it as is. Now, why is this so sweet? Well, it's so sweet because this little integral dude just means area, and it's the area of this function, which is right there. So all I got to do is find the area. So let's do it. It's 3 minus, what's the area? Well, from -5 to -2, that is a 3 by 3 square, so it's 9, but I got to be very careful. That's below, so this right here would have an area of -9. Okay, and then right here I'm dealing with a little bit triangle, 1/2 base times height, which would be -3 halves, right? Because it's a base of 1 and a height of 3. And then I got to go this little length. Oh, snap, there's no area there. And then what does it say I have to go to? I have to go all the way to positive ichiban, +1, which is that right there, which is 1/2 base times height, and that would be a 1. If I do all of that work, I'm going to save us some time. I get 25 over 2. And yes, this would be a non-calculator. So be careful simplifying that. Hopefully it was okay. Now this one on the 2018 test was worth 2 points, this little piece right here. All right, remember, pause, rewind, do what you need to do to get better at these guys. Remember, probably I failed to say it, I apologize. Probably the best way to get good at these problems is to hit pause, try it yourself, and see if you got the right answer. Okay, evaluate 1 to 6 of g of x dx. Now, g of x, remember, is just f prime of x. Okay. It's this graph down here. Well, this is kind of interesting here because we all know that this bad boy right here means the area from the curve to the axis, right? That's what it means. And if you look here, we already did this. That's -9. That's -3 halves, right, class? That's 0, and that's 1, right? We've already done that part, correct? Oh, snap. Come on, Mr. T. Come on. No, we haven't. I'm going from 1 to 6. What you doing, my man? So I'm going from 1 to 6. That's just from, oh, that's why I did it. 1 to 3 is a 2 by 2, so that's 4. Well, how about that? Well, if that area is just 4, but that's from 1 to 3, oh, darn it. This next from 3 to 6 is a curve. And I can't use my old school geometry formulas to find me that area. So what should I do? I'm just going to break it up. And now I'm going to go from 3 to 6. And they give me the function, you guys. That's exactly why they give it. 2 times x minus 4 squared dx. Okay, so I got this 4 hanging on. I'm going to bring that 2 on the outside. All right, now what I need to do is I need to take the antiderivative of this guy here. Now remember, if we're not good, we're using u. And in this situation, I would make my u, right, let u equal x minus 4. And then it's just u squared. And we all know what the antiderivative of u squared is. It's just u to the third over 3, right? That's all it is. Now remember, if my u is x minus 4 and I take the derivative of u, which would be 1 du, the derivative of x minus 4 would be 1 dx. Now remember, whenever you do u sub, if you get a derivative of 1, you don't really need u sub. So let's save some time. I get 4 plus 2, right? If I said it was u to the third, we would say it's u to the third over 3. So instead, it's x minus 4 to the third over 3. And then I have to evaluate that from 3 to 6. So now I just got to do some math. I don't know about you, but I would bring that 3 out. And so I would get, sorry, it's getting a little jumbled here, but 2/3, that's all coming out. And then it's just x minus 4 to the third. I'm going to evaluate that from 3 to 6. I apologize writing on my face. So I get 4 plus, I get 2/3. If I plug the 6 in there, I get 8. If I plug the 3 in there, I get 1. -1 actually, right? 6, right? 2 to the third is 8. That minus, right? Fundamental FTOC. That's where that comes in this problem, right? -3 minus 1 is -1. -1 to the third is negative. So that's going to turn to a positive. That's a 9. 9 divided by 3 is 3, 2. So my final answer is 10. That would be worth 3 points. Okay. So far, a total of 5 here for this 2018 number 3. All right, let's go ahead and go to C and D. Remember, hit that pause button, you guys. See how you can do on your own. All right, C. It says -5 to 6 for -5 to 6. So that's the entire graph over there. On what intervals is f, which we don't know, but this is f prime, right? Is f, the original graph of f, increasing and concave up? Give a reason for your answer. Okay, everybody at home, hopefully our first thought gets is f prime is increasing whenever f prime is greater than 0. So what's helpful? I tell you to do these the way we do them in class. What would be really helpful is to do a little sign analysis. But what's interesting here is this. Let's look. This is the graph of f prime here. Now, what goes on our f prime sign analysis? Critical points, whenever f prime is 0 or DNE. And f prime is 0 or DNE whenever the graph is 0 or DNE. So it's 0 from -1 to 0. It's kind of interesting. The whole thing is 0, right, you guys? And then also from 4 at 4. Okay, it's 0 because it hits the little x-axis there. And then this stuff is negative here, positive here, and positive here. So guess what that means? That means f is increasing. Okay. Oh, it says when is f increasing and concave up? Okay, so I'm going to just hold off a little bit. But remember, this means the original graph of f will decrease here, then increase, and then increase. But the question says when is it increasing and concave up? So now we got to deal with the second derivative. And everybody at home, say it with me right now. A graph is concave up when the second derivative is positive or greater than 0. So let's set up that sign analysis. Now, once again, what do I put on sign analysis? Well, whenever it's 0 or DNE. And the second derivative now, this is the first derivative. So how do I find the second derivative, positive, negative, and 0 values? Well, if this is the graph of the first derivative, the second derivative would be the slopes. So when do I have 0 slopes? Believe it or not, you have 0 slopes from -5 to -2, right? So that's all going to be critical points. All of them. Okay, and it also is from -1 to 0. Oh my gosh, there are so many 0 slopes on this graph. This is just crazy talk. It's also 0 slopes from 1 to 3, right? Those are all 0 slopes. And are you serious right now? I also have a 0 slope at 4. That's kind of crazy, right? But it's true. Now let's go 0, 0, 0, 0, positive slopes. That means the second derivative would be positive. Then you have your 0 slopes. Then it's positive again. Okay, ooh, I missed one. It's positive right there. And then when I get to 3, actually, all of these slopes are negative, right? And then after that, they're positive. So this question is asking, okay, when is f going to be increasing and concave up, concave up, concave up, concave up. So let's see where we kind of, oh, it looks like from 0 to 1, union from 4 to 6. That is where it looks to me. Let's make sure I got it right. Booyah! But then guess what? I've got to give a reason. And the reason's as okay as this, believe it or not. I'll give you the good and the great reason. The good reason is that, hey, that's my answer because that's when the first derivative is positive and the second derivative is positive. Okay? Or you can use your graph right here. How did we use that graph? Well, it's the points where f prime or the graph of g is above the x-axis and when the slopes of g are positive. Both give me this interval of 0 and 1 and 4 to 6. Okay, and that was worth 2 points right there. A lot of that just to get the 2 points. All right, but remember 15 minutes per question, and it's good to time yourself when you're going through these guys. All right, here we go. D, find the x coordinate of each point of inflection of the graph of f. Well, how the heck do I find the x coordinate of a point of inflection? Well, hopefully it's ding, 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 ding. That means second derivative. Now remember, I just had it drawn out here, so I'll do it real quickly again. Let's put the critical points here, -1 to 0, critical points, 1 to 3. Remember, there's a ton of when the slopes are 0, and then that 4, it's a slope of 0. And then it's positive, and then it's positive, and then it's negative, and it's positive. And remember, what does it mean to be a point of inflection? A point of inflection for the graph of f would happen when the second derivative changes signs or changes from increasing to decreasing or decreasing to increasing when looking at the f prime graph. When the only part where that happens is at x equals 4. And some people at home, I know, you're saying, well, what about 1, 2, and 3? Well, it doesn't change signs, right? It changes from a 0 to a negative. And that's the big difference there. So it's x equals to 4. And the reason why is because the second derivative changes signs. Or you could say because the graph of g changes from a decreasing slope, a negative slope, to a increasing or a positive slope. And that would be worth 2 points if you're able to get that right. Now, the interesting thing about today when we go through our lesson, you guys, of getting ready for this AP exam, every single year, 2018, 2017, 2016, 2015, all have questions that deal with graphs, and your job is to be able to interpret those graphs, all right? So that's what we want to get good at today. And if you didn't pause in the 2018 test, I challenge you to pause yourself right now. Okay, they ask me in part A here to find f of -6, and they ask me to find f of 5. Can I do it? Let's check it out. Let's get my answer key up so I can let you guys know how much each point is worth as we go through this problem. Okay, so let's look at it. I got a whole bunch of shapes over here. I got this, graph of f prime, very similar to the one we just did, right? But at least they just tell me this time, right? And then I've got some semicircles, some triangles. It's crazy, this graph. But they do give me kind of an initial condition. They say f of -2 equals 7. And they asked me to find f of -6. Well, what do I do here? Remember what we did last problem? And hopefully you unpaused it now. We're f of -2 because that's what they give me. Well, I want to use that guy. And whenever you use an initial condition, they always give you 1 punto, 1 point. Sweet. All right. And then what is that? Plus, and then I got to go -2 is what I'm using. So I go -2 to -6. Now, if you recall, that's backwards. And you can go backwards except when looking at a picture. When looking at a picture, you do not want to go backwards. If you're really super good, you can, but I like to be safe. F of -2 is 7. And then I'm going to go from -2, and this is sometimes where I make mistakes. Make sure you're on the right points. -6 to -2. So that'd be this stuff. That would be 1/2 base times height. What would that be? That'd be a +4 area. So right now it's +4, okay? And then I go all the way to -2. Oh, sweet. Is that done? I think that's done, but oh no, Mr. T, you forgot something really important. You guys know what it is? And that is, remember when I flipped it here? What do I have to remember to do when I flip it? I have to change that sign. So it's actually going to be 7 minus 4, which is 3. And believe it or not, ooh, that would be worth 2 points so far. You get a third point for part A if you're able to get f of 5 correct. Now let's go ahead and look at f of 5. Same thing. Now hit pause if you didn't do that first one on your own, right? When you start feeling success, it feels good. Heck yeah, it does. Remember, we got to start at that negative, at that f of -2. But now I'm going to go -2 to 5, and that's normal, right? That's normal limits right there. So I don't have to flip anything. So I'm 7 plus. All right, -2. Oh, snap. That's a semicircle from -2 to 2. From -2 to 2, that's a semicircle. That'd be 1/2 pi r squared. That's a radius of 2. So I get 2 pi, but it's below, so I better make it -2 pi. And then I've got to go all the way to 5. I got a little triangle there. That'd be 1/2 my base, which is Ichi-ni-san, which is 3 times a height of 2. So that's 3. So if I do this all correctly, I get 10 minus 2 pi. Sweet, I got it right. Part A, worth 3 points. Okay, so they really value that you're able to use initial conditions and graphs to help you to get these answers. Okay, all right. Part B, on what intervals is f the original graph, increasing? All right, just went through this. Hit pause, guys. It's real similar to that 2018 test. Well, remember, f prime, I want to know when it's greater than 0, right? That would be when it's increasing. And that's kind of my reason for it, right, you guys? So I'm going to do a little sign analysis because that's what we do in class. Now, what do I do as sign analysis in class? Well, sign analysis for f prime, which could tell me about increasing and decreasing, I want to put the zeros. And I got zeros, boom, boom, and boom. That's when f prime is 0. At -2, at 2, and at 5 where it ends. And then where is my graph? Where is f prime? It's above, so positive, below, negative, above, so positive. So my answer is as quick and easy as this. It starts at -6. So from -6 to -2, it is increasing, f is, and union 2 to 5. And I want to say that on those intervals, f is increasing. Okay, I'll write a little reason out for this one so you guys get really good. Because f prime of x, I should put of x, come on, let's be complete, is greater than 0. What would that guy be worth right there? That guy right there would be worth 2 points. So if you were able to do parts A and B, class, that's 5 points right there. And remember, the whole goal is these questions are going to change every year. There's just going to be little twists, and they're going to look different. So it's very important to make sure you are trying this stuff on your own. All right, part C. Okay, part C, let's take a look at this. They're asking me for a min. A min, and it says the absolute minimum value. Okay, we've got to really think here. So absolute minimum value. Now, when I see that word value, it means the answer's got to be a y value on the closed interval from -6 to 5. Well, when I see that minimum, dude, same thing. I should be thinking first derivative. And I'm going to redraw my sign analysis. I know it gets annoying here on my screen, you guys, because I've got to keep on redrawing these things. There's just not enough room to have everything. All right. And if I look at this, okay, that's good. That was above positive, below negative, above positive. Now, remember, I asked you to do this when we were doing these, when we were learning about minimum and maximums. Your graph of F, this is going to be F, will increase, then decrease, and then increase. So where could my possible minimums be? My minimum could be here or at a possible endpoint. I'm including, right? There's brackets there. There could be a minimum right there. So remember, what do I do when I find out the possibilities? Well, we always like to write mins and maxes. We like to do a table. So we have our x, and then we're going to go f of x, which would be y, correct? Because it's the y value. All right, so my possible x answers would be -6. And believe it or not, I already found out what f of -6 was in that first step. And the answer was 3. Now, I really should check endpoints, but there's no way at 5, right, that's going to be the answer because you can just tell that that would be a max, right? But f of 5, I found that in the first, which is 10 minus 2 pi. And yes, you should know that pi is 3, right? So that'd be about 4-ish. Okay, that'd be about 4-ish. And so the minimum probably happens right here at 2. Okay, so I'm going to have to find out what f of 2 is. All right, and yes, hopefully you're saying it at home. That's a critical point too. But f of negative 2 is not going to be a minimum. So here I just have to do f of 2. Now, how would I do that? Well, I would do f of negative 2 plus from negative 2 to 2 of f prime of x dx, right? That's going to give me the value. And if you remember, f of negative 2 is 7, right? And then, hey, negative 2 to 2 is where the limits are, but then I'm going to find the area of that semicircle, which we did already, and it's below, so it's going to be minus 2, right? And we already said this. Pi is 3, that'd be 2 minus 6. It'd be like Ichiban or 1, which would be your minimum. So that would get you your answer. Now, that was only worth 2 points. And I think the reason why it was only worth 2 points is because we used a lot of the information that we previously had written down. All right. Whew. For each of f double prime of negative 5 and f double prime of 3, find the value or explain why it doesn't exist. Okay, second derivative. Second derivative would mean, well, this is the first derivative. Remember, very similar to 2018, but asking it in a different way, right? F double prime would be the slopes. Okay, so where's negative 5 at? Ooh, negative 5 is this guy right here. Well, what's this guy's slope? Ah, that's linear. That's just rise over run. So how do I get from this guy to the other guy? I go down 2 and over 4. Well, what's down 2 and over 4? That'd be negative 1/2. Boom, point for that bad boy. F double prime of 3. Well, where's 3? 3 is boom. Pointy place, right? Because f double prime is the derivative of this, which means it's the slope of it, which pointy place corner means D N E. Point for that, but then remember, it said to explain why it didn't exist, so you would have to make sure you explained it. And the best way to explain whenever we have a pointy place, remember, is to say the slope, right, the limit, as we approach 3 from the left of f prime of x does not equal the limit as x approaches 3 from the right of f prime of x, okay? Or actually, that's nice and easy Japanese. And to be completely honest, to be really safe with this bad boy, I would simply just say, class, that it's a pointy place, and your limit or your slope as you approach from the left-hand side does not equal the slope as we approach from the right-hand side. Are we all good to go? Actually, I should put an f double prime right there, right? Because that's f prime. All right? Okay, so that is 2017. This video is getting kind of long, but you know what? I want you guys to dominate this. We still have 2 problems to go. Here we go. Number 3, look at that jigsaw puzzle. All right, here we go. I'm going to just keep on rolling. Part A, hit pause, you guys. Get better and better at these. Okay, does G have a relative min, max, or neither at 10? Well, this is the graph of F. Ooh, this one's kind of interesting. This one's a little bit different. That's the graph of F. Okay, and they're asking me about this guy here. Ooh, we're really using the fundamental theorem of calculus here. All right, part A. All right, so if I want to know if G has a min, max, or neither at 10, I've got to find the derivative of G. So here we go. This brings up the derivative of an antiderivative. Do you remember that? And there's a shortcut. And it is you just take the variable and you plug it in. That's it. That's it. Now, if G prime of x equals f of x, then G prime of x, right, I have to do a sign analysis, okay, to find mins and maxes. Now, when is G prime 0? Well, it's going to be whenever f is 0. And f is 0 at negative 2. It says it right there on the graph. At 2, at 6, anywhere else? Oh, and at 10. And they did ask about 10. And then G prime of x, or the graph, is below, above, above, below, below. So what does G look like? that means G is going to look like this. It's going to decrease, then increase, then decrease, then increase, then decrease. Ooh, I feel like I made a little bit of a boo-boo there. It's going to decrease, then increase. Oh, snap, I did. Gosh darn it. I'm going to do it here in blue, you guys. I knew there was a boo-boo. Decrease, then increase, then increase again, right? And then decrease again. So if blue is my graph, and I apologize here for the boo-boo, but if I erase that, and if I looked at 10, 10 is right here, this graph. Even though there happens to be a critical point there, it is neither. And so what would the AP want you to say for that guy? All right. Well, if I'm looking here, I'm at the, what am I at? The 2016 test, and we're on number 3. What you would say is that it's neither a min or maximum because G prime of X goes from negative to negative at that point, or decreases, right? It decreases before 10, it decreases after that. And how did I know that? Because my sign analysis, right? I erased it, but it was negative before 10, it was negative after 10. And believe it or not, you would just get, that was only worth 2 points, you guys. That's it. I feel like that was a lot to take in, a lot to write down, and it was worth 2 points. But my best guess is we're going to be doing stuff like this throughout this entire problem. All right, does the graph of G have a point of inflection at x equals 4? Well, point of inflection, what should our thought be, class? It should be second derivative. But they're asking us about G, so we want to find the second derivative of G. Well, remember, the first derivative of G was just f of x. So the second derivative of G would just be f prime of x. So once again, I'm going to set up a sign analysis for the second derivative of G or the first derivative of f. Now, why do I have to use the first derivative of f? It's because I'm given the graph of f. And what goes on that? Well, f prime would be the slopes of this. And the slopes would be where you would have a 0 or a DNE slope. And there's a lot of DNE slopes here. There's a corner right there. Remember, that would be a DNE. I'll put an open circle. Oh, there's a corner at 2. Open circle. The slopes from the left and right do not equal each other. Whoops, corner there, corner there. Another guy, what's going on here? Another guy, 8 and 10. So there are a lot of critical points on this graph. Now, what are the slopes? F prime, what are the slopes? Positive, then negative, then positive, then from 4 to 8, they're negative. I'm not making a mistake this time. Oh, they always flip-flop. So all of those are points of inflection. How about it? So guess what you would say? You would say, yes, there's a point of inflection at x equals 4. And make sure you guys write down these reasons. Okay, and what's my justification? Because the second derivative changes signs. Or you could say because the slope of f changes. And if we're focusing here on 4, it changes from increasing to decreasing. And that'd be the answer that they would love to hear. Now, guess what? I know it's disappointing, but that dude was only worth a point. So for A and B, that was a lot of work. You would have got 3 points if you got all of that correct. So that means these remaining 2 are worth a ton of points. Once again, this is tough. Find the absolute minimum value. If you notice, that's kind of been the commonality here. When we find a min or max, they are asking us to find the value. And they're asking you to find the min max for G, or G. So that means I'm going to find the derivative of G, which, remember, I told you this already. We already did that, right? That's equal to f of x. Okay, and remember, there were a lot of these guys, all right, which is -2 is a critical point because it's 0. 2 is a critical point. What else? 6 is a critical point because it's 0, and 10 is a critical point because it is 0. And then if I look at my graph, it's below, it's above, it's above, it's below, and it's below. All right, so let's go ahead and look at this. What would be minimum possibilities? Remember, change my color here. It's important to look at what the graph is. I'll draw the actual graph of G in red. It will decrease, so that could be a min, then increase, then it's going to increase again. That would be a possible max up there. Then it would decrease, and then it would decrease. So would this be a min? We already said no, but either it's between these 2 guys right here. Now, Remember, you're technically supposed to check endpoints, okay, whenever you do these values. So the AP is really particular on this one. They want you to check your X, G, oh, and this is G of X, remember, because it's the value. But your possible answers, you know, it could be an endpoint, but we all know it can't be -4. We all know it can't be, right? It's got to be a max, right? I can tell by my sign analysis, all right? It could be -2 for sure. There's a critical point at 2. There's a critical point at 6. Could be 6, I guess. We already know that it's not, though. And you could say, looking at my sign analysis, I know it can't be that. Or it could be at the very end, which would be at 12. So guess what? I need to find out what G of -2 is, and I need to find out what G of 12 is. Well, G of -2 would be the integral from 2 to -2 of f of t dt. And guess what? Those limits are backwards. So I better flip them. Boom, right? And all I got to do for that, you guys, is from -2 to 2. How about it? That's just a triangle. That's just 1/2 base times height. That, correct, is simply, let's see, that's a 4 by 4, 1/2 base times height. That'd be 8, but it's a negative. So my answer for that would be -8. Okay, only other guy I got to check is G of 12. Well, G of 12 will be what's that? That's 2 to 12 then. So 2 to 12, I don't have to flip those limits, but boy, do I got to find a ton of areas, right? Let's go from 2 to 12. So I got to account for that. What would that be? That'd be 4, 4. That'd be 16. So that would be 8. Ooh, this is negative though, right? This is negative, and that's a 4 by 4 also. So that's going to be -8. And then I got this little piece here is 2 by 4. That'd be 8. I get -2 because I got to take half of it. So for this answer right here, ooh, I feel like I made a little bit of a boo-boo, did I? That'd be 2, 4, that'd be 8, that'd be 4. Okay, that answer would be -4. So my minimum value would be -8, and it happens at x equals -2. Holy moly, that was worth 4 points. Okay, a lot to consider in that. If you want to know the breakdown of the ultimate scoring, remember, you can always look that up. All right, let's see what our very last question is. And our very last question says for -4 all the way to find all values for which G of x is less than 0. Oh, okay. So now, and this is what? This is worth, oh, this would be worth 2 points. Okay, so in order to consider this, all right, we need to know what G of x is. And G of x is equal to the integral from 2 to x of f of t dt. Okay, so there's a lot of things to consider here. I know one thing is I'm going to start, let's say, if I start at 2 and I go this way, right? We already had that was 8, that was -8, and that was -4. Do you kind of remember that? But remember, if I say like what's G of 4, or I'm sorry, G of 0, or G of -2, or G of -4, I've got to account for all of those, right? G of -4 would actually be equal to the integral from 2 to -4. So there's a lot of stuff I have to consider here. And remember, those are backwards limits. And whenever they're backwards limits, I got to think of this right here. Right, class? And so from -4 to 2, well, this says, let's go ahead and find all of these areas, and then that's 2 by 4. If that's 2 by 4, that's -4, right? This area here is a +8, okay? But if I go from -4 all the way to 2, it's going to be -4 plus 8, which is 4, but it's negative. Oh, how about that? So that's going to give me negative values. So there's a lot to look at in this problem. But to get to the end story here, your G of x, right, your G values will be negative from -4 until +2 union 10 to 12. Okay, and that's because I've got to account for all of that. Now, this video is getting really long. I am not even going to go through the last problem that I had for you guys, but I'm going to show you which one it is, and you are going to want to do it for homework. Okay, it's 2015. It's one of these same types of questions we've been doing. Make sure you do that. Make sure you pause these videos when I'm doing them with you. For this one here, I challenge you to do it. I challenge you to look up 2015 AP Calculus AB scoring guidelines, and you can get all the answers there. Aloha!